So, good morning, everyone. So, what I'm doing now is going to give examples regarding heat, energy, calorimetry, and enthalpy. So, these were given during your quiz for the problem solving part. So, what I'm going to do is I'm going to solve some of the problems that were given during the quiz, and for you to be able to check your answers, and then also to give you a walkthrough of how I'm solving the problems, because there were questions raised regarding decimal places, rounding off, what's the range of values for that specific problem. I only solved six here, but the six are very similar to those you saw during the exam, so that you can actually recheck your answers. Okay, so I divided it into three parts. I'm doing heat, calorimetry, and enthalpy. So if you also go back to the test, there were no questions regarding potential and kinetic energy. We'll just do that maybe in the next few examples that we will have. Okay, so for heat, the formula that we have been using for the different examples and also for the activity as well as the quiz was this formula, which is, of course, mc delta T, the basic formula for heat. Okay, Q here is your heat, and then usually this is in joules, and then of course M, that will be the mass of the object, and this is usually in kilograms or grams. Okay, and then we have C. C here is the specific heat capacity. So for each object, it's different. This is usually in joules per gram degrees Celsius. That's why, as I've said during the previous videos, you have the, because there's another unit. So this is a joule gram Celsius. Make sure that this is also in grams. I think that's where the mistakes came in or came from. It's the conversion of the units. And of course, finally, delta T. When you see a delta, that's always final minus initial. And it's all sometimes T2 minus T1 or TF minus TI. Okay, so it depends on what formula you'll be using for sub 2, sub 1, F, sub I. It doesn't matter as long as when it's a delta. That means it's change. It's always final minus initial. Okay, so let's start with two problems. First one, it says here, an iron piston in a compressor has a mass of 3.62 kilograms. If the specific heat of iron is 0.449, how much heat is required to raise the temperature of the piston from 12 to 110, 111 degrees Celsius? Express your answer in kilojoules. Okay, this was one of the controversial uh, questions I had. So some of you were pushing me that the Canvas answer is incorrect, that you were getting the correct answer. So I'm gonna do it. I'm gonna do the walkthrough. Okay. So first, of course, just like any problem, this is actually just a heat problem. It's very simple. Okay. Let's get the given. Pardon my my pen. I'm still not used to it, but getting there. So mass is 3.62 kilograms. This is where most of you had a mistake. It's 3.62 kilograms, but if you can see here, your specific heat capacity is in joule per gram degree Celsius. So we have to convert this first to grams. So converting it, you multiply that by 1,000, that's 3,620 grams. Okay, I hope that's okay there. Now, C now is equal to 0.449 joule per gram degrees Celsius. And from the problem, you can actually solve it right away. T2 minus T1, that's 111 minus 12 in degrees Celsius. So that's basically just inputting the values in the formula. So that's Q equals MC delta T. So that's 3620 multiplied to 0.449 multiplied to 111 minus 12. So if I'm getting a Q there, this is where most of you had that problem, because you can see from here, this is, you didn't convert anything here. You probably, what you did was multiply 3.62 times 0.449 times the delta T, but you still have to convert it to grams, because this is still in kg and that is in joule per gram degrees Celsius. So that's a gram, so this should be a gram. So what I'm getting is, I actually solved them a while ago. I'm pushing my answer, since I was telling you that the answer was actually correct, the one in Canvas. The exact answer is, sorry, did I erase something now? It's 160,912.62 in joules. But the problem is asking an answer in kilojoules. So therefore Q is equal to, of course, just divide that by 1,000, 160.91 kJ. So I'm expecting this one. I hope that's clear. Okay. I hope if there should be questions, maybe it's, you can jot them down, note them down, and then you can ask me on the discussion board or on our group chat, or when we have our sync classes, you can ask me. I'll gladly do the computation again. Okay, so this is our final answer. There you go. It's 160.91 kilojoules. You get 5 points for this. Okay, the next one. Okay, I solved another one. So just to strengthen that, let's move me here. There you go. So camera conscious. So it says here, how much energy is needed to raise the temperature of 8.5 times 10 to the second power gram block of aluminum from 22.8 to 94.6 degrees Celsius. The specific heat capacity of aluminum is 0.9 joule per gram degree Celsius. And now it's asking us for the answer in joules. So you don't have to do anything, no conversion whatsoever, because I'm seeing everything to be consistent. So let's get the given mass is 8.5. Just be careful in pressing your calculator for the keys. If you're having problems, let me know. If you're not too familiar with your calculators, we can do calculator practice. So this is in grams already. And then we have a delta T. Our delta T is from 22.8, so that's initial. So the final is 94.6 minus 22.8. No need to convert anything there. And then C, the specific heat capacity of aluminum is 0.9 okay, joule per gram degree Celsius. So what to do? Well, just put them into the formula. So let's just do the space. Q is equal to MC delta T. And then, of course, your clever calculators with you. Times 10 to the second power. That's grams, so it's consistent with this. Okay. Multiplied by C, which is 0.9. Multiplied to 94.6 0.6 minus 22.8. So Q here is, what I got was, the answer is in joules. So I already compared them if you want to check. I can also upload this, my handwritten solutions for better handwriting, because I'm so not really so, my handwriting is not that clear sometimes using the pen, but try my best. So our final answer is 54927 joules. Okay. No need for conversion. So I think your exam range, if I'm not mistaken, was for this problem 54900 to 54930. So if your answer was within that range, you're getting the 5 points. Okay. Excuse me. Okay, let's go to the next one. Okay, now for calorimetry, you're still using the same formula. It's just that you're comparing most of the time two materials. Or in calorimeter, there's one which will gain heat and the other, of course, will lose heat. So the basic formula for calorimetry is Q gain is equal to the negative Q lost. Okay, let's just clarify which gain, which lost. Of course, Q gain, it means it gains heat. So it's the one increasing the temperature. And then for negative Q loss or Q lost, it lost the heat, meaning it gave away its heat, so it cooled down. So that will be the premise. That should be your orientation. Q gain will be the one accepting the heat or the one that increased in temperature, when Q loss will be the one that gave out heat, which means it cooled down. It transferred its heat to the other object or to the other material. Okay, to strengthen that, let's have two problems also. It says here 136.51 grams aluminum rod. The specific heat of aluminum is 0.9, is at 100 degrees Celsius, and placed into a 250 grams of water at 21.8 degrees Celsius. So what we're looking for will be what will be the final temperature of the system at equilibrium, assuming no losses to the surroundings. Assume that the specific heat of water to be 4.18 joules per gram degrees Celsius. And of course, we're looking for the final temperature in degrees Celsius. So this is a classic example of what I was telling you a while ago. So it says the formula is Q gain is equal to negative Q lost. It's actually just comparing two heats, because definitely when you immerse one, for example, this rod is immersed in water, and you can see that the rod is really hot and water is at a very low temperature, lower than 100 degrees. Tendency would be the hotter object would make the cooler object warmer, and the tendency for that hot object will be to cool down. Okay, if in this example, like what I've said, Q gain, which will heat up. So which one would gain the heat? That will be water. Because it says and placed into, and then Q loss will be aluminum. So you'll just compare the two MC delta T's. That's MC delta T of water is equal to the negative, of course, MC delta T of aluminum. Okay, so let's get the given or just plug in the values. Okay, water. So water is at, okay, initially it's 250 grams. And then C of water is 4.18. Delta T, it says we're assuming D2 minus 21.8, because we really don't know the final temperature of the system is equal to negative The M of the aluminum rod, it's 136.51. The C is 0.9. In this case, it was initially at 100, so T2 minus 100. So you might feel that it might be wrong because this is a negative 100, but there's a negative here, so tendency is you can actually just really solve it. And doing your math in your calculators, T2 here is what I got a while ago is 30.02. You guys know the shift solve thing, so just enter it as it is, degrees Celsius. So for the quiz, the range of values that I allowed was 30 to 30.4. So I hope you got that right. Okay. So let's move further. Let's have another one. A 50 grams sample of water at 100 degrees Celsius was placed in an insulated cup. Then a 25.3 grams of zinc at 25 degrees Celsius was added to the water. The temperature of the water dropped to 96.68. What is the specific heat of zinc? And please express your answer in joule per gram degrees Celsius. Okay, so again, our basic formula. Okay, that will be Q gain is equal to negative Q lost. Because sometimes if you really can't identify which is which, tendency will be you're putting the one with the negative sign on the wrong side. So that would make your answer erroneous. So you really have to understand which gain, which loss. So here, 50 grams sample of water at 100 degrees was placed in an insulated cup. So we have water and zinc. So I believe that zinc would be the one gaining and water will be the one losing heat. Okay, all in there, of course, as always, just input the values. Okay, this is MC delta T of zinc is equal to the negative MC delta T of water. Okay, so for zinc, let's look at the given. 25.3. The C of zinc is missing. That's the one missing. Okay, delta T. So for delta T, the temperature of the water dropped to 96.68. That will be our final temperature. So 96.68 minus initial temperature of zinc was 25 is equal to negative. So M of water 50 times C of water, that's 4.18. By now you should have, at least remember it because we've been using it all the time. And then this will be 100 minus 96.68. Is that correct? Let's check that again. Am I doing correctly? Let's check it. Or that's 96.8. Okay. Yeah, I guess it is. That's correct. Because the final, oh, I'm sorry. I think I made an error here. Let's place, this should be, uh-oh, there you go. That's why I said there was something wrong to it. Let's erase this. I interchange. Okay, let's do that again. Okay, so final temperature here. See, it's 90. Okay, that's 96.68 minus 100. Okay, we're good. So all you have to do now is get C So C now is, well, if you want to like really see the whole thing, that's -50 times 4.18 times 96.68 minus 100 divided by 25.3 times 96.68 minus 25. So RC now, I got 0.382 joule per gram degree Celsius. Okay, there you go. I hope you got these correct answers during the quiz, okay? So the range of values I gave during the quiz were for this number 0.38 to 0.39. So if your range of value is within that quantity, then you get it correct. You get 5 points. Okay, now for the last two problems, they involve enthalpy, and also I wanted to share something because for the true or false or identification part of the test, there was something about liquid to solid. Okay, I said I was replying to some of your messages saying that please look at it in the view of enthalpy. Besides, you could have practice elimination there. So here, as I've said, this will be the checkpoints. So here we're using heat of vaporization and we're using heat of fusion. Okay, so for that answer, in a general level, I know very well that you said it's liquid to solid, that's freezing. And solid to liquid is, of course, melting, but the whole thing on a general level is fusion. So if it was in this area, in this process or part of the process or part of the block, this is vaporization, okay? I just wanted to clear that. I know that the answer should have been freezing, literally, but on the choices given, it was actually asking for a generic term. So the answer there is fusion. Okay. Okay, let's have two problems. How many kilojoules of heat are needed to completely vaporize? I'm sorry, that was moved. 50 grams of water at 100 degrees Celsius. Okay. So this is just unit conversion. So first, understand that it's water, and we have 50 grams of water. Okay, and we also know that for water, in moles, because that's H2O, H2O, let's get the molar mass. So H, it's 2 times 1, then oxygen is 1 times 16. So this is 18 grams per mole. And as I've said a while ago, it's just really unit conversion. So we have 50 grams times 1 mole is equal to 18 grams, right? So we're actually eliminating grams already. And we have a given. It says here, we can use this one. Okay. We have that 40.67 kilojoule per mole. So 40.67 per mole. And what do you get? Let's put it here. Just multiply that. Where's my calculator? So that's 50 times 40.67 divided by 18. I'm getting 112. Okay, that will give you, okay, I think I have to reconsider some answers. I'm not sure if you were able to answer or input 112.97 in that numerical text box, but I will check your answers individually. For those who got this, and they were marked wrong, my apologies, but this is the correct answer, okay? And lastly, this is just a review. Okay, calculate the energy in joules required to convert 2.7 grams of ice, originally at -15, into steam at 105. So given the following data. So, okay, I think I need, can I insert a slide? Is it possible to insert a slide? Okay, just insert it here. Let's okay, I'm just gonna solve that here. New slide. Okay. Yeah, sorry, that will happen. No. Okay, just put that here. Okay, and then let's solve it. Again, I'm just gonna pattern my solution. We were looking for something in joules, I think. Yes. Okay, that was ice to water. Okay. So the process is actually ice, sorry, not ice to water, it's ice to steam. Okay, there you go. So the initial temperature of ice was -15 degrees Celsius to steam at 105 degrees Celsius. And then it was, the mass of ice was 2.7 grams. So it's straightforward. I just want to pattern what I'm gonna do, and I hope you got it also correct. This gave you 10 points in the problem. So first one will be, of course, ice to ice. Okay. The second one will be what? Ice to water. I'll explain later. Third one will be, of course, water to a certain temperature of water. And then the fourth one will be water to steam, right? And finally, the fifth part will be steam to steam. Okay, what happened here? Oh, okay, let's do that again. I think I entered something. Okay, tech. Okay, so the last part is, there you go, steam to steam. And when it's, you can see ice, 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 water, 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 steam, steam, steam. When it's the same phase, then you're using an MC delta T formula, because there's just a change in temp, not a change in phase, okay? And this is ice to water, so this is M delta HF, and this is water to steam, that's M delta HV. Knowing that, you can just put in the values. In this case, we're looking for Q total in joules, so no problem in conversion. So first one, ice to ice, MC delta T. So this is equal to 2.7. And then we go back. What will be the C of ice? It's 2.11. And then delta T, that's 15. Okay. And then ice to water, that's an MHF. So that's 2.7. And then heat of fusion is what? 334 from the table. I won't refer to the table. I have it here. I have a small table also. I have a cheat sheet. I don't memorize them. I just check my cheat sheet. And then water to water, that's a 2.7 again. And then that's 4.18 because you're bringing it to a boil, that's 100. Okay. And then water to steam, that's a 2.7 multiplied to HV. Our HV is, I think, 2258. Okay, And finally, steam to steam. That's an MC delta T. That's 2.7 times C of steam. It's, let's go back to the table. C of steam is 2. Okay, 2 and then times 5. Okay, and then all you have to do is add them all up together. I got an 85.455 here. Here I got a 901.8. I got an 1128.6 here. Here I got a 6096.6. Yeah, this one's supposed to be the biggest because of the HV. And finally here I'm getting a 5.4. Is that a 5.4 times 5? Right? That's 2.7 times 2 times 5. And I'm getting a 27 here. That's correct. And finally, my answer, Q total here is, sorry, it's my Q total. Well, I'll just add them all up together. Okay, that's 85.455 plus 901. 901.8 plus 1128.6 plus 1696.6 plus, okay, I'm getting an 8239.46. So that's in joules. So some of you were asked for the final answer in kilojoules, some in joules, some were given at 270 grams. So but this is just the pattern. I hope you get it. It's just really a 5-step pattern. We're trying to convert ice to steam. Okay, so hopefully at this point, I will be confident. I'll be giving my confidence to you that you can solve problems involving heat, enthalpy, and calorimetry. Okay, so for now, for my 2 sections, for my TTH class, there'll be an activity for you right after watching this video. Okay, so I hope this helped. If there should be questions, please don't forget to jot them down, and then please ask for our group chats. And we have a discussion board or your inbox function in Canva. So I hope you can share this also to your other batchmates. They can still watch the video. Okay, hopefully this helped. And till the next video, okay? Goodbye.